Ever wondered how the Earth was formed or why continents move? It's a question that has puzzled humans for centuries, sparking curiosity and feeding our insatiable desire for knowledge. The Earth, as we know it, is a dynamic planet, ever-changing and evolving, its continents drifting like giant puzzle pieces on a molten surface. But what causes these colossal landmasses to shift and reshape? This puzzling question led to the birth of a revolutionary concept in the early 20th century. A concept that not only answered these questions, but also changed our understanding of the Earth and its history. This is the concept of continental drift, a theory proposed by Alfred Wegener, suggesting that the continents we see today were once part of a single massive landmass that has drifted apart over millions of years. As it turns out, these movements are due to a phenomenon called continental drift. Scene script. Enter Alfred Wegener, a German meteorologist and the main character of our story. Born in Berlin in the late 19th century, Wegener found himself captivated by the mysteries of the Earth. He was not just a meteorologist, but also a polar researcher, geophysicist, and most importantly, a daring thinker. His curiosity and keen observation led him to propose an idea that would forever change our understanding of the planet. In 1912, Wegener suggested a groundbreaking concept, the continental drift. He proposed that the continents we see today were once a single, unified landmass. He called this ancient supercontinent Pangaea, a name that fittingly means all Earth in ancient Greek. Over millions of years, he believed Pangaea broke apart, its pieces drifting slowly to their current locations. But Wegener's ideas were not immediately accepted. Why, you ask? Wegener's theory was based on several compelling pieces of evidence. He pointed to the jigsaw puzzle-like fit of the Earth's continents, most notably the snug alignment of South America and Africa. He also noted the striking similarities in fossils and rock formations found on separate continents, suggesting they were once part of a unified landmass. But perhaps the most persuasive evidence came from the distribution of ancient climates and glaciers. The remnants of tropical plants in Arctic areas and glacial deposits in warmer regions were clear indicators of a shifting world. However, the scientific community largely resisted Wegener's theory. Despite the compelling evidence, Wegener's inability to explain the force behind the drift was a significant stumbling block. He speculated that the Earth's rotation or some sort of astronomical precession could be responsible, but these explanations were met with skepticism. While Wegener couldn't explain the mechanism, future discoveries would eventually shed light on this mystery. Fast forward to the 1950s and 60s, new discoveries breathed life into Wegener's theory. As technology advanced, scientists started to uncover compelling evidence to support the idea of continental drift. Seafloor spreading was one such discovery. This process, where new oceanic crust is formed through volcanic activity and then gradually moves away from the ridge, demonstrated the fluidity of the Earth's crust. Alongside this, paleomagnetism, the study of the record of the Earth's magnetic field in rocks, provided evidence of the continent's movement over time. Then came the advent of sonar technology, allowing scientists to map the ocean floor in unprecedented detail. This revealed the mid-ocean ridges and deep-sea trenches, further suggesting that the Earth's crust is in constant motion. These findings culminated in the concept of plate tectonics, proposing that the Earth's surface is made up of large plates that shift over time. These advancements not only validated Wegener's theory but also expanded it. Continental drift was more than just a theory. It was a revolutionary idea. This concept, once deemed radical, forever changed our understanding of the Earth. It acted as a catalyst for the development of the plate tectonics theory, a cornerstone of modern geology. Now we know that the Earth's crust is not a static shell, but a dynamic jigsaw of plates. These plates, moving atop the underlying mantle, are responsible for the creation of mountains, the rumble of earthquakes, and the eruption of volcanoes. The legacy of continental drift is immense, extending far beyond the scientific community. It has influenced how we explore and exploit natural resources, how we predict natural disasters, and even how we understand the distribution of life on Earth. Continental drift was not merely a theory, but a key that unlocked a deeper understanding of our dynamic and ever-changing planet. Thanks for joining us on this journey through the story of continental drift. Remember, our planet is always on the move.